Hi, I'm Timur,
And I'm Arthur.
and today we will be teaching you how to calculate the current in a given circuit. I will be explaining a series circuit.
And I'll be explaining a parallel circuit. But first, let's talk about what we'll be calculating. I will give you a brief explanation of the measures and specific values in our equations. First, we'll be talking about voltage. Voltage represents the amount of energy given by the power source, and it is measured in volts. Then, we will talk about current, which is what we will be calculating. Current, to put it simply, is the speed at which energy can move through the circuit at any given point. And it is measured in amperes, or amps for short. Now, finally, we'll be talking about resistance. Resistance is measured in ohms, and it is quite literally the electrical resistance experienced by the energy in the circuit. Resistors slow down the circuit, as the name would imply. Take it away.
So, since I'm going to be explaining the series circuit, I have to tell you the values. Now, you should have it in front of you, but I'll just tell you now, just to make sure we're on the same page. I have created a circuit with two resistors, having 6 ohms and 4 ohms respectively. There are 3 batteries that are 10 volt batteries each. Of them has 10 volts. Together they have 30 volts. So before we begin with the calculations, let's take note that at any point in the circuit you can measure the current. There's no different section for measuring it. On a series circuit specifically, in parallel circuits it's different, but you can measure it with the ammeter at any point. So, you're cheating just a little bit because you actually get to see what we're calculating, but I'll go through the steps. The equation we're going to be using is I equals V divided by R. What does that mean to the non-physicist? Current will be equal to the voltage divided by the total resistance of the circuit. Since my resistors are 6 and 4, they equal 10 ohms, respectively. We know that the total resistance is R, and we now know the total resistance of volts. That is 30, since I have 3 10-volt batteries. So it's just a simple calculation of 3 divided by 10, which is 3, which matches up with the image you see.
Thank you, Timur, for that explanation of a series circuit. Now, parallel circuits are a bit more complicated, and it is very easy to get confused with values and numbers when dealing with them, so pay very close attention to what I'm saying. Firstly, the easy bit. My values for this equation in this specific circuit. My voltage is 48 volts, and it all comes from a singular battery. My 2 parallel resistors each give a resistance of 10 ohms. Finally, I have 2 different readings for my amps or amperes, 4.8 amps and 9.6 amps. I will explain why this happens after calculating the resultant or equivalent resistance. For parallel circuits, resistance R is found by the equation 1 divided by RA plus 1 divided by RB plus 1 divided by RC, and so forth, where R plus whatever letter was put after it equals 1 resistor's resistance. Since my circuit only has 2 resistors, my equation will simply be 1 divided by RA plus 1 divided by RB. So now I shall plug in my known values, where RA is 10 ohms and RB is also 10 ohms. Now if I calculate that out, I will find that the resulting resistance is 5 ohms. And I will explain why the current ampere readings are different. Now I will explain why the current ampere readings are different. When you add another resistance in parallel...
Did you catch that? He forgot to do a step. Do you know what it is? I didn't think so. He forgot to he added the values of 1 divided by A and 1 divided by B, but then you have to divide 1 by that value. Did you do that?
In the calculation.
In the calculation, but they don't know what you're talking about. So just to clarify, once you have 1 divided by A plus 1 divided by B, you divide 1 by that number, which equals 5 in this case.
Timur is right. I should not have left that out. Now, on to explaining why the current ampere readings are different between the two halves of the circuit. When you add another resistor in parallel with the first one, essentially you have just opened up a new channel through which more current can flow. No matter how large or powerful the second resistor is, the total current flowing from the power supply will always be higher than when there is only one resistor. Now, this is true because each of my resistors has a resistance of 10 ohms, and the resultant resistance is 5 ohms, 50% of their individuals. That is why part of the circuit is reading a current of 4.8 amperes, and the other has a reading of 9.6 amperes. Note that 4.8 is exactly half, 50% of 9.6. Now that all of that is out of the way, we must verify that the ampere readings are correct. The equation that I shall be using to solve for current is I, which is the denotation for current, equals V, voltage, divided by R, resistance. Now, I will find from that the current in relation to the two resistors is 9.6 amps. However, if there were only one resistor of 10 ohms, the current would be the lower value at 4.8 amps. We hope that this has helped you understand circuits a little better.